Welcome to Topic 4, Collecting and Summarizing Data. Now, data is just a collection of facts from which conclusions can be drawn from. And there are two types of data. We have attribute or discrete data, and then we have variable or continuous data. Now, attribute data is countable and only includes integers such as the number 2 or 40 or 1050. It answers questions like how many, how often, and what type. Some examples of discrete data would be like the number of defective products or the percentage of defective products, possibly the frequency of machine repair or the type of awards received. With variable or continuous data, this can be measured and includes any real number, such as 2.045 or negative 4.42 or 45.65. It answers the questions of pretty much how long, what volume, and how far. Some examples would be height, weight, or the time taken to complete a task. Now, the first step in the measure phase is to determine the type of data required based on some considerations. The first one being what variables have been identified for the process. So those would be critical to quality parameters or key process output variables or key process input variables. Another criteria would be, well, what type of details are selected? Now, the type of data that fits the metrics for this key variable. And then a third one would be, why should the data type even be identified? And this enables collecting, analyzing, and drawing inferences from the right set of data. Now, it is difficult to convert attribute data to variable data in the absence of assumptions or additional information, which can include retesting all of our units. Now, the 4 measurement scales begins with a nominal scale. Now, a nominal scale will have data that consists of only names or categories, and ordering is not possible. It is considered the least informative of all the scales, and the mode is used as the measure of central tendency. So an example of a nominal scale would be a bag of balls containing the following colors: 10 green, 5 black, 8 yellow, and 9 white. Another measurement scale that could be used is ranking or ordinal. Now, this is where data is arranged in order and values can be compared. The median or mode is typically the measure of central tendency. So for instance, an example would be restaurant ratings of A-3 or B-5 or C2 or D4. Another measurement scale is the interval. Now, this is used for ranking items in step order along a scale of any equal points, such as the mean, median, or mode that can be used for central tendency. So temperature of 3 metal rods, which are 100 degrees Fahrenheit, 200 degrees Fahrenheit, and 600 degrees Fahrenheit, is a great example of intervals. And the last measurement scale would be the ratio, where this represents variable data and is measured against a known standard or increment. However, this scale also has an absolute 0, so no numbers exist below 0. The median or mode, as well as arithmetic, geometric, or harmonic means can be used. Example of ratio would be mass, length, or maybe even an electric charge. So to ensure that data is accurate, data sampling is carried out. Now, sampling is just the act or process or even a technique of selecting an appropriate sample from a group or population. So there are a couple of types of sampling. The first one being random sampling. And this is where the sample group is chosen from a population at random. Then we have sequential sampling. Now, this is a non-probability technique where a single subject or group of subjects is selected for a period, then they're analyzed, and then followed by the next sample. The next one would be stratified sampling. And this is where samples are taken from each stratus or subgroup of a population. Now remember that stratified sampling gives an accurate estimate of a population parameter. So what about simple random sampling versus stratified sampling? There are some differences between simple random sampling and stratified sampling. With simple random sampling is very easy to carry out. The possibility of any erroneous results is high, and the type of sampling cannot indicate possible causes of variation. With stratified sampling, it is very time-consuming and requires a lot more effort. The possibility of error is minimized, and when done correctly, it is capable of showing assignable causes of variation. So let's talk about some data collection methods, the first being check sheets. Now, a check sheet is just a structured, prepared form for collecting and analyzing data. It is a generic tool that is relatively simple to use and can be adopted or adapted for a variety of purposes. Now, check sheets can be used when data can be observed and collected repeatedly from the same individual or from the same location. And it's also used when data is collected from a production process. So in this example, we see absenteeism in an organization. We have the day of the week in the first column, the number of absences in the second column, and then the total in the third. So on Monday, as absenteeism increases, our check marks increase. And on Monday, we had a total of 27 check marks. And then through Tuesday, Wednesday, Thursday, and Friday. Now, data coding is the process of converting and condensing raw data into a category and set so that it can be used for further analysis. Data coding can offer some benefits, such as it simplifies large quantities of data, and it enables easy entry of the processed data into computers. It facilitates data analysis, it enables organized data representation, and it eliminates data repetition. So let's talk about descriptive statistics. So a measure of central tendency is a single value that indicates the central point in a set of data. The three most common measures of central tendency are mean, median, and mode. Now, mean is the most common measure of central tendency, and given by the sum of the entries in the data set, and then that's divided by the total number of entries. It's also called the average or arithmetic mean. Now, the median is also known as a positional mean. It's the number in the middle of all of our data sets. Now, the mean of the middle two numbers in the event of an even data set, we would take the mean of those. So we would add them and divide them by 2 to get the median. Now, the mode is also known as the frequency mean. So this is the value that occurs most frequently within your data set. So let's do an example. So for the following data set that you see here, let's calculate the mean, the median, and the mode. So our data set is really simple. It's 1, 2, 3, 4, 5, 5, 6, 7, and 8. Now with the mean, what we would do is add up all of those numbers and divide by 9 because there's 9 units of data. That would equal 4.56. Now the median, remember, is the middle data point, which in this case is 5. And then the mode is always the number that is repeated most frequently, which in this case is also 5. So what about outliers? Well, the data set is modified to include a new value. So instead of just 1 through 8, now we have the number 100. So let's go ahead and calculate our mean, our median, and our mode. So the new mean with that 100 being placed in our data set is equal to 15.11. So almost 90% of the values fall to the left of our mean. Now this mean is skewed due to the presence of an extreme data point, which is 100. So that 100 is called an outlier. The median of this data set stays unchanged at 5. So when the data set has outliers, the median is always preferred over the mean as a measure of central tendency. Now, measures of dispersion describes the spread of the values. The higher the variation of the data points, the higher the spread of the data. The three main measures of dispersion are range, variance, and standard deviation. So range is just defined as the difference between the largest and the smallest values of data. So in the data set that appears here, the range is calculated as followed. We take our maximum, which is 9, and we subtract our minimum, which is 1. Gives us a range of 8. Now, variance is defined as the average of the squared mean differences and shows the variation within the data set. So let's consider the following data set of 4, 8, 1, 6, 6, 2, 9, 3, 6, 9. Let sample variance can be calculated using the formula in Excel, which is the VAR or variance point S, open parentheses and close parentheses. Now this population variance can be calculated using this Excel formula as well. So the sample variance would equal 8.04 using that Excel formula. The population variance is going to be 7.24. Now variance is a measure of variation that cannot be considered as the variation within the data set. Population variance is preferred over sample as it's a more accurate indicator of the variation. So another measure of dispersion is standard deviation. Now standard deviation is just the square root of our variation. So using that same data set, we can see that the population standard deviation is 2.69 because we'll be using the Excel formula listed here. Now our sample deviation is 2.83 using the sample standard deviation formula in Excel. So how do we manually calculate standard deviation? The first step is we have to calculate our mean, and then we calculate the difference between each data point of the mean and square each of the answers. Then we calculate the sum of all those squares and divide by the sum of the squares by the total number that we have. And then we find the square root of that variance.